Here's a question that might sound a bit stupid. How long is the coastline of the United Kingdom? You'd think that by now someone would have figured that out. We've got satellites, GPS and drones, and we've even mapped out the surface of Mars, so surely we'd know the length of our own little island. Well, here's the thing, we don't. The official government estimate is around about 11,000 miles long, and other organisations put the length of the coastline to 19,000 kilometres. That's a difference the size of crossing the Atlantic Ocean twice, but technically speaking, both of those figures are correct. It all depends on how you measure the coast. So let's say, for example, we want to measure the UK's coastline. It's quite simple, right? We just grab a ruler and measure along, but in our case we're going to be using Google Maps just to make things a bit easier. So let's try it. Let's take a figurative ruler that is 100 kilometres long and line that up along the coast. That 100 kilometres takes us from Buchan-Ness Lighthouse to Lunan Bay Beach, and you can see that we miss out a majority of the intricacies of the coast, meaning that measurement isn't really that accurate. Now though, let's swap that for a 50 kilometre ruler, so it's half the length, and a shorter ruler will allow us to follow the coastline a bit more closely and to bend it more to fit around the jagged nature of the coast. Now, our distance travelled using the same 100 kilometres is less than using a straight kilometre ruler. Now, after using two 50 kilometre rulers, our distance travelled is a lot less, although we use that same 100 kilometres, that technically makes the coastline longer. Now let's turn things up a notch and use a 10 kilometre ruler. This will allow us to follow the coast even more closely. You can see that the total is 100 kilometres, and that takes us from Buchan Bay Lighthouse to Elephant Rock, quite a far distance from Lunan Bay. Now obviously that's on a very granular level, but you can imagine that if we use an even smaller ruler and measured even more detail and captured even more curves, the coastline would become a lot longer. For example, if we use a 5 kilometre ruler, a 1 kilometre ruler, or a metre stick, or even go centimetre by centimetre, the smaller the ruler shrinks, the more the coastline grows. Now this isn't a measurement error, it's not even a rounding problem, it's actually a fundamental property of how the British coastline and most natural coastlines actually work. This is called the Coastline Paradox. In 1967, a mathematician called Benoit Mandelbrot, the man who gave us fractals, published a paper with a deceptively simple title: How long is the coast of Britain? His answer was essentially, it depends. And the shorter your measuring unit, the longer the coast appears to be. And he came to that very simple conclusion because the shorter your measuring unit, the longer the coastline appears to be without limit. And here's why. When you use a long ruler, you skip over the little bays, the rock formations and the inlets. And when you draw a straight line across them, it's fast and it's tidy, but you're missing the intricate details that make the British coastlines. So a shorter ruler catches more of these curves and more of the intricacies of the coast. If you zoom in enough, you're going to end up measuring every boulder, every single pebble, and even every grain of sand. The UK's coastlines, and in fact any coastlines, aren't smooth, and that's why they're what mathematicians call fractals, shapes that look similar regardless of how much you zoom in. The same jagged, irregular pattern at 1,000 kilometres looks the same at 100 kilometres and at 1 centimetre. Mandelbrot calculated that the British coastline has a fractional dimension of 1.25, somewhere between a line and a surface. That's not a whole number, and that's the point. In nature, coastlines don't behave like ordinary geometric shapes. A straight line has a dimension of 1, and a flat surface a dimension of 2. The British coastline sits in between, and it's too complex to be a simple line, but it's not filling the whole area either. The further you zoom in, the more detail that you find, and because of that, the measured length grows towards infinity. That's not a metaphor. I mean, mathematically, if you keep on reducing the size of the ruler, the measured coastline would have no upper bound, which means it can go on forever and ever. Now you might be thinking, okay, it's just a bit of fun maths, it's meaningless, who actually cares? Well, actually quite a lot of people care. For example, governments care, because maritime law is based on the distances from coastlines. You've got fishing rights, territorial waters, and exclusive economic zones. In addition to that, the legal zone where a country controls its own resources extends 200 nautical miles from the coast. If you can't agree on where the coast starts, how can you even agree where the law ends? Environmental agencies care as well. Conservation bodies that are trying to protect coastal habitats need to map them. And if your baseline measurement varies by 70%, depending on your method, then planning policy becomes a mess. Shipping and navigation also care. Charts have to be accurate to maintain a consistent standard. A chart that zooms in more than another will show hazards that others miss entirely. And this isn't a problem that's just in the UK. The paradox applies to every single country in the world with a coastline. The most extreme example of the coastline paradox is Norway, which is estimated to have anywhere between 25,000 kilometres of coastline and 100,000 kilometres of coastline, just depending on the measuring unit used. That's a four-fold difference for the same piece of land. The UK, though, is actually a near-perfect case for this study, and this is for a few reasons. Firstly, Scotland. Scotland's western coastline is extraordinarily jagged. You've got lochs that cut deep inland, hundreds of islands, and inlets within inlets. It accounts for a disproportionate share of the coastline's variability. Secondly, the islands. The UK has over 6,000 islands in total, for example the Shetlands or Orkney. And how about that random rock that sticks out of the sea in low tide? The answer actually matters legally as well because it determines maritime zones. Thirdly, you've got the intertidal zones. Now the coastline isn't a fixed thing, it moves twice a day with the tide. At low tide, the UK has considerably more coast than at high tide. Now most measurements use mean high water or mean low water as a baseline, but it's still a choice that someone somewhere in an office had to make. So the next time that someone tells you that Britain is a small island, politely point out that its coastline may be longer than the circumference of the Earth, depending on how pedantic you want to be. What's interesting about this paradox is that it's not just about maths, it's what it tells us about how we think about measurement. We assume that physical things, such as land, has fixed objective properties. The UK has a size, a coastline has a length. These are facts that are stored somewhere just waiting to be looked up. But the coastline paradox shows us that measurement is always a choice because you choose the scale and you choose the resolution. And different choices give you radically different answers, all of which are technically correct. This is something that keeps coming up in science, in economics, in data, and the answer that you get depends enormously on how close you choose to ask the question. The UK doesn't just have one coastline though, it has an infinite family of possible coastlines, each one valid and has its own resolution and changes on a daily basis. So the next time that someone asks you how big the UK is, you can tell them the official answer. It's about 243,000 square kilometres. But as for the coastline, you can tell them that no one really knows, and now you can tell them why. If you found this video interesting, there is a whole lot more from where this video came from. I upload videos every single week about random British unique questions, and I make sure to answer them every single video. So please do be sure to subscribe, and I'll look forward to seeing you in the next video. Thank you very much.